Greetings, calculus scholars. Today we're going to be talking about section 3.1, the derivative and tangent line problem. Folks, this is a huge deal in terms of calculus. This is one of those major ideas in calculus that is really at the core of what you're going to talk about for the remainder of the year. But before we do that, let's remind you of what a tangent line actually is. Here are three different pictures of different tangent lines. When we think of a tangent line, we probably go back to that definition of what we had heard about in geometry when we were talking about circles and lines that are tangent to circles. And you were told at that point probably that a tangent line only touches the circle at one point. And it's very much true over here for this particular graph. You'll see that the line only touches that curve at one point and wouldn't touch it anywhere else along that. But it doesn't necessarily have to be exactly like that. Like you'll see in this curve, yes, that line only touches the curve in one spot, but do you see how it kind of passes through the curve? It really kind of doesn't fit that same type of definition we had from geometry. And then we go over here to this third graph. And this third graph, well, look, yes, it has a tangent line there, but you'll see if you extend the line further, it will cross the curve a second time. So we have to be really careful about what a tangent line is and our definition of what a tangent line is. So before we start talking about lines that are tangent to curves, let's talk about lines that are secant lines to a curve. If you remember back from your definition in geometry of a secant line, it is a line that passes through a circle at two different points. Sometimes that's a diameter is a great example of that, and sometimes it's a diameter, but it doesn't necessarily have to be. In this diagram that I have over here on the left of the screen, you'll see a secant line. That blue line is a secant line. See how it crosses your graph twice? And when we're calculating a secant line, we would do that just like we would with any other line. We would figure out what the slope of that blue line is. We'd figure out what the change in y over the change in x is. We'd be able to figure out what the equation of that is. Instead of figuring out what the equation is, we're simply going to focus on the slope, the change in y over the change in x. These pictures that are over here on the left, you'll see what happens when we make that change in x smaller and smaller and smaller and smaller. You'll see we end up with a tangent line. Or we could think about changing our delta y, making our delta y smaller and smaller and smaller, and you'll see we'll end up with, again, a tangent line as well. If you go to the notes that I have uploaded into Canvas, and you actually download this slide presentation, there's a really cool Desmos app that you can mess around with. So if you click on that link will be live and you go directly to that Desmos app. And I would encourage you to pause the video right now and go do that. No, really, go ahead, pause the video. I'll be here when you get back, promise. Yeah, I'm not going anywhere. Pause the video. This brings me to the most important thing that we're going to talk about here for the next couple weeks. The definition of the derivative. The definition of the derivative is right here in front of you. This right here, this little symbol, it's f with a little what is that, like an apostrophe of x? We say f prime of x equals the limit as delta x approaches 0 of, hey, that looks really familiar. That's the difference quotient. Remember that? Sometimes you use h instead of a delta x, but this is the difference quotient. There are other symbols that we use to represent the derivative that you'll see throughout the year. We'll focus probably on those first three. They all mean the exact same thing. We may just represent them in different ways. We'll talk more about those throughout the year. So how does the definition of the derivative work? I'm going to show you now with this example problem. So we're going to look at the derivative, use the definition of the derivative to find the derivative of f of x equals x squared minus 4x. The first thing I would absolutely encourage all of you to do is to write out the definition of the derivative. So f prime of x equals the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. Encourage you to write out that definition every single time, at least for a while. Now, we're going to actually apply that formula. So f prime of x equals the limit as delta x approaches 0 of, okay. So first thing we're going to do, We're going to take a look at this first part, the f of x plus delta x. So what's that look like? Well, this is where I'm just replacing the x in my original equation with the x plus delta x. So that'll turn out to be x plus delta x squared, that's this part, minus 4 times, that's this part, x plus delta x. That takes care of the first part of this formula. Now let's do the second part. Let's do this minus f of x. So minus the f of x. Well, that's just me writing out the formula again. And we're going to put that whole thing over delta x. All right. So now, in the next step, what I'm going to do is I'm going to simplify it. What you'll see is I've actually FOILed this right here, the x plus delta x squared. That's where this comes from. I've distributed the negative 4 into that parenthesis. That's where this is coming from. And that's all I basically did so far. Let me continue to simplify down. You'll see I've dropped the parentheses here and distributed my negative sign over here on that second half of the problem. Now, if you've done things right, what you should see is you should see some things start to cancel out. Like this negative x squared and this positive x squared. And this negative 4x and this positive 4x. And if you've done it correctly, what you should end up with is you should end up with nothing but terms that have a delta x in them. And that's your really good check to see. That's got a delta x, that's got a delta x, that's got a delta x. Because what you want to see happen is you want to see all of those delta x's go away. Let me show you. So I factored my delta x out of the top. That was pretty easy to do because all the terms had a delta x in them. And now if you notice, there's a delta x here on the top and a delta x here on the bottom. And what happens is they can cancel each other out. When they do, I'm left with f prime of x equals the limit as delta x approaches 0 of 2x plus delta x minus 4. Now, actually notice something. I actually forgot to include the limit as delta x approaches 0 there. Notationally, that's kind of important because do you see how I have it throughout the problem? I still need it there, and I forgot to put it in the previous step. Sorry about that. So now what I'm going to do is I'm actually going to take the limit. I'm going to take the limit as delta x approaches 0, and that means I'm going to take and I'm going to replace delta x with a 0. That will give me this expression that the derivative of x squared minus 4x is 2x minus 4. Now, we'll talk more about the significance of what that actually means, but for now, we're just going to calculate these derivatives. We're going to find them by hand. Let's look at another problem, the square root of x minus 1. So the first thing I'm going to do, as always, is write out my definition of the derivative. Now I'm going to use my equation and rewrite this difference quotient. Now I'm going to sit and stare at this problem and try to figure out what the heck I'm going to do. Because I can't combine like terms. There's no like terms here to combine. So what am I going to do? I'm going to multiply by that magical form of 1. And I'm going to try to figure out how, or I'm trying to cancel out some things here to make this problem easier to simplify. So I'm going to multiply by the conjugate. So when I actually go through the top and I actually go through and FOIL here, or I remember that shortcut, I end up with the square root of something squared. And that parenthesis, essentially the squared and the square root would go away in both the end and the first and the last term there. So I end up with x plus delta x minus 1 minus x minus 1 over that mess that I got going on the bottom. And no, I'm not going to multiply out the bottom when I do that. But if you did this correctly, you should see again, everything that doesn't have a delta x cancels out. So you see this x and this minus x, this negative 1 and this plus 1. They cancel each other out. And again, we're left with only a delta x on the top and on the bottom, which again will cancel out. Now remember, that doesn't mean there's 0 on the top. That when they cancel out, that means there's just a 1 that's left over. So now I have the limit as delta x approaches 0 of 1 over this crazy expression that we have going on. However, what I'm going to do now is I'm going to substitute in 0 for delta x. And when I do that, I will get x plus 0 minus 1 plus x minus 1. And what I get when I do that is 1 over 2 square roots of x minus 1. They both end up being the same thing. And that is the derivative of the square root of x minus 1. Let's do one more problem here together. So again, I'll start by writing out the definition of the derivative. Now I'll fill in my f of x using the difference quotient. Now I'll simplify this. And how will I simplify this? Well, I'm going to get a common denominator. I see two fractions, I'm going to get a common denominator. So my common denominator is simply going to be what the other fraction was. So you'll see that delta x plus 3, I'll multiply by x plus 3 over x plus 3. And then with my other fraction, I'll do what was on the denominator of the other one. So that x plus delta x plus 3 over x plus delta x plus 3. Now I'm going to simplify things a little bit more. You'll see rather than dividing by delta x, I'm going to change it so that I'm multiplying by 1 over delta x. It just makes the math just a little bit easier to deal with as I'm writing this all out. I'm going to go ahead and skip a step where I'm going to already put this over its common denominator rather than having to write it separately. This will just make the process just a little bit easier. So you will see that when I do that and I go down to my next step here and I start distributing through the parentheses and seeing what's going to combine and cancel out, let's see here. The x plus 3, I'll have a minus x, I'll have a minus delta x, I'll have a minus 3. And again, it's over that messy denominator. But more importantly, what you will see is you will see that this x and the minus x cancel out. And that plus 3 and that minus 3 cancel each other out. And then what am I left with? I'm left with a delta x on the top and a delta x on the bottom of the fraction, which again will cancel out. Now I can apply my limit by replacing the delta x with a 0. And I end up with a final answer of -1 over x plus 3, that quantity squared. That's actually my derivative of 1 over x plus 3. Hope you got something out of this video, but now it's time for you to practice a couple more of these basic derivative rules. So good luck with that, and if you have any questions, please let me know as always.